Example number 4. Use the following function to answer parts A through C. F of x equals x cubed plus 6x squared minus 30x minus 35. List all the rational zeros that are possible. Use synthetic division to find 1, and then reduce it down to find the remaining zeros. Now remember, it's got 3 maximum because it has a power of 3. So we're looking for 3 zeros or less. Okay? Can't have more than 3, but it can have less than 3. So the first thing is, you might try this by factoring, and I want to show you this so you'll see that they don't always factor. If I take out an x squared, I get an x plus 6. These have a 5 in common. If I take out a 5, I get a 6x minus 7. These don't match. I can't bring them out. That means factoring won't work. Okay? You always group the first two and the last two and drop your middle sign. Take out your GCFs, and if you don't have a matching binomial, you know that this polynomial will not factor. Now, that doesn't mean that it won't factor at all. It means it won't factor by grouping. So we're going to have to use a different method, and we'll use synthetic division. And luckily for us, 35 doesn't have that many factors. So plus or minus, the factors of 35 are 1, 5, 7, and 35. And that's over the factors of 1, which are all 1. So it's plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. So my recommendation, start in the middle. So I'm going to start with 5. So 5 is going to go into my coefficients and count 3, 2, 1, none. So I know I can put 1, 6, negative 30, negative 35. I'm going to start with the 5. So drop your 1. 1 times 5 is 5. Add, I get 11. 5 times 11 is 55. Add negative 30 and 5 to get 25. 5 times 25 is 125. And minus 35 plus 125 is 90. So f of 5 is 90. So I'm going to try negative 5. So I'll put my negative 5 here. 1, 6, negative 30, negative 35. I'll drop my 1. Negative 5 times 1 is negative 5. I get a 1. Negative 5 times 1 is negative 5. I get negative 35. And negative 35 times negative 5 is positive 175. So I get a 140. So that's not a 0, but f of negative 5 would be 140. No luck so far. I'm going to try 1. I don't know why, but I'm just going to try 1. So 1, 6, negative 30, negative 35. Drop the first 1 down. 1 times 1 is 1. Add, I get 7. 1 times 7 is 7. Add, I get negative 23. 1 times negative 23 is negative 23. Add, I get negative 58. F of 1 is negative 58. It's not a 0. So far, no luck. I'm going to try negative 1. So negative 1, and I'm going to divide into 1, 6, negative 30, and negative 35. Drop my 1. Negative 1 times 1 is negative 1. Add, I get 5. Negative 1 times 5 is negative 5. Add, I get negative 35. Negative 1 times negative 35 is positive 35. Add, I get 0. So this is a 0. F of negative 1 is 0. Now, I haven't tried all of them. I've tried the 1 and the negative 1. I've tried the 5 and the negative 5. I could go back and I could divide by the plus or minus 7 or the plus or minus 35, but I'm just going to take a look at this polynomial. It's a trinomial. The power has gone down by 1, so it's x squared plus 5x minus 35. So x squared plus 5x minus 35 equals 0. Now, if this was a 4-term polynomial like we had at the beginning, and we tried to factor it, and it didn't factor by grouping, that's different from x squared plus 5x minus 35. Okay? You don't need to try any more factors in this because you know the rule for factoring trinomials. What it says is that if it factors, you take the factors of negative 35 that add up to 5. So negative 1 times 35, negative 5 times 7, negative 7 times 5, negative 35 times 1. And you'll notice that none of those add to 5. Now that doesn't mean that this doesn't have 2 more answers. It just means all rational roots have been found. There are no other rational roots. However, since we were able to get one root out, we can use the quadratic formula on this quadratic equation. Can't use it on a cubic, but you can use it on a quadratic. X is the opposite of b plus and minus the square root of b squared minus 4ac, all of that divided by twice a. Our a is 1, our b is 5, and our c is minus 35. So the opposite of b would be a negative 5 plus and minus the square root of 5 squared minus 4 times 1 times negative 35. All of that is twice 1. So that's going to give me negative 5 plus and minus the square root of 25 plus negative 4 times 1 times negative 35 is a plus, and 4 times 35 is 140. So all of that's going to be over 2. So negative 5 plus or minus the square root of 165 over 2. And see, this tells us that these are irrational solutions. Irrational numbers cannot be written as fractions. They're going to be decimals that never repeat, and all we can do to that is try to reduce it. Now, the only way you can reduce a square root is if it has a perfect square factor in it. So I'll look at the perfect squares that are more than 1 and see if I can find something that might go into 65. So I'm just listing them up to 100. Well, 100 is too big. It won't evenly divide into 165. 81, let's see, 81 into 165 is 2 point something, so it's not going to divide evenly. You could try 64 and 49 and 36, but really the only real possibility is this 25 because it ends in a 5. So you'd need to check to make sure that you know for sure none of those go, and since none of those will go, this is our final answer for the other 2 zeros. Now, on this particular problem, they ask us to give decimal estimates. These are the exact solutions along with -1. So we could go ahead and write a solution set with these two irrational answers there. But they did ask for decimals, so we'll go ahead and write them as decimals. So -5 plus the square root of 165 over 2, and -5 minus the square root of 165 over 2. So to get that decimal, do -5 plus the square root of 165. That's about 7.8452. And I'm going to go one more decimal place. Then I'm going to divide that by 2. And I get that this is approximately 3.923 to 3 decimal places. Then -5 minus the square root of 165 is about -17.84523. Divide that by 2, and I get that it is approximately -8.923. So the final answers in the format they asked for were -1, 3.923, and -8.923. And these are actual real zeros. If you draw the graph, they would be x-intercepts, but you would have to estimate their locations.